Today we are going to learn about pushes, pulls, and their impact on motion. First, let's think about some sports that include a ball. Pause this video while you think. Here are some potential answers. There's basketball, soccer, tennis, and baseball. Now there are plenty of other sports that include a ball, so most of your answers I'm sure are right. Let's choose one to focus on, like soccer. So how would you move a soccer ball? You'd probably kick it, right? So if you were trying to kick a soccer ball towards the goal, you'd kick it at a certain speed. But if you moved away from the goal, would you change the strength of your kick? You'd probably have to kick it further, so you'd have to therefore kick it harder with a higher force. So before we start our experiments, we're going to learn some quick vocabulary because we're going to need it for our questions. So a force is a push or a pull on an object. So like pushing a cart or pulling a door open. And forces impact motion, as you can see on the video on the right. So for our experiments, you're going to need a ball, so this could be a marble, a soccer ball, and I used a tennis ball, and an inclined surface. So I used books and a ruler. You could use blocks and some cardboard or like a Hot Wheels track or anything else you can come up with. So for our first experiment, we're just going to use a light push to move a ball from the top of an incline. You're going to repeat this using the same push strength starting from the bottom of an incline. And then you're going to use that same push strength again and push the ball both left and right on a flat surface. As you can see, it's being pushed down and then up with the same push strength, and then to the left and right on a flat surface. So, does the ball move further when it went up or down the ramp? And does the ball move in the same direction that you pushed it from? Feel free to reference those videos as you answer these questions, and then put your answer in the Jamboard if you're comfortable with that. Check out the Jamboard if you want to see other people's responses as well. We're now going to move on to our second experiment. You're going to start with the ball on a flat surface and you're going to push it lightly in one direction, observing how far it went. You're going to repeat this 3 times or so, pushing slightly harder each time. As you can see, it starts with a very light push, and the push increases each time. When you push the ball harder, did it travel further each time? And when you push the ball, does it move in the same direction that you pushed it from? Reference the video if you're stuck, and then add your answers to the Jamboard. So, does the ball always go further when you push on it with more strength? You can reference the videos again if you're stuck, and it would be great if you could add your answers to the Jamboard and look at other people's responses. So what are some ways you apply a force to something? Some examples could be like kicking a soccer ball, closing a door, like by pushing it, things like that. And which has more force, dropping or throwing a basketball? So our final discussion is going to have 2 similar cars driving in opposite directions on a track, with car 1 traveling slightly faster than car 2. Both cars slow to a stop. Now you're going to try and predict the motion of each car in relation to each other. There will be some sample answers on the Jamboard, and it would be great if you could add your answer to that as well. So now we have our Scientist of the Week, which is Valerie Thomas. So she managed the development of NASA's image processing systems, and she developed systems to support satellites. She designed a concave mirror system to produce optical illusion images. And she was also the Space Physics Analysis Network project manager, and she advocates for increased diversity in STEM, which is super important. So she's super cool. If you want to check out more information about her, there are some links below. But we're reaching the end of our lesson. Again, use the Jamboard if you want a more discussion-based format and to see some sample responses. Thank you so much for watching, and I hope you've enjoyed this video.